Finding the determinant by cofactor expansion.
Good day everyone, welcome to our math video tutorial. So for today, I'm going to teach you on how to find the determinant of a matrix of order 3. So let's first discuss the matrix A. So I have here an example. I have the first row, which is a 0, 2, and 1. The second row, we have 3, -1, and 2. And then the third row, we have 4, 0, 1. When we say 3 by 3, we have 3 row and 3 column. And that's as what we define as the 11, A11, C11, A12, C12. When we say A11, which means A to the first row and to the first column, and C11 the same as the A11. We say it as the C first row and the first column, followed by the A12 and C12. When we say A12, we say A to the first row and to the second column, and when we say C12, likewise with the A12, we say A to the first row and to the second column, and so on. So we typically use to express our determinant by locating it to the first row as our basis. So here, let's define the determinant of this matrix A, 0, 2, 1, 3, -1, 2, 4, 0, 1. So we have here the two vertical bars surrounding by the name of our matrix, and equal to the A11, C11, minus or subtract to the A12, C12, add to the A13, C13. And that would be our formula in finding the determinant of the matrix of order 3. So our A11 here is the first row and first column element. So we have 0 element, and then our A12 here is our 2, and then A13 is 1. And our C11 here is -1 because we have to cover the 0 to 1, the first row, and then the first column. So we got the remaining dimensions. -1 times 1 equals -1, 0 times 2 equals 0, so -1 subtracted to the 0, we got the -1. So in order for us to determine the cofactor, we just repeat the procedure in getting the cofactor. But we know that our cofactor is what we do process to cover the given dimensions, such as the C11, C12. We have first row and second row, and that's how we do step by steps. So in our C12, we have to cover the first row, which is the 1, and then the 2 is the second column. So cover the first row and then the second column, and let's multiply the remaining dimensions. We have 3 and 1. In the second column, we have the remaining dimensions, which is the 3 and then the 2, and then the third column, or third row, we have here the 4 and then 1. So multiply that in terms of 2 by 2. Determinant, finding the determinant of matrix. So we got 3 times 1 equals 3, and subtract this by 4 times 2, we got -5. And then our A13 here is our first row and then the third column. So let's cover the first row and then the third column. We have here the remaining dimensions, the same as what we do step by step on getting the C11 and the C12. So our C13 here will be the result of 4, because 3 times 0 equals 0, and minus 4 times -1, so negative times -4 is equals +4. So our resulting equation here will become from A11 C11 plus A12, but A11 C11 minus A12 C12 plus A13 C13 will become 0 times -1 minus 2 times -5 and added to 4, because say we usually, speaking of formula of the cofactor, we got here as A11 C11 minus A12 C12 plus A13 C13. But our ideal way on determining this in a formal format, we usually follow the instruction, which is we're just going to add, and then by the use of the sign patterns for cofactor. For the simple way on finding the determinant of the such matrix, we can have to use these equations. Here we have here the formula of definition of determinant of A, which is the two vertical bars surrounding by the name is equals to A11 times C11 minus or subtract this to A12 C12 and add to C13 or A13 times C13. So that's a simple way, or the other way or alternative way on solving the determinant of cofactors. So we got here the resulting equation of determinant of A, which is 0 times -1 plus 2 negative times -5, or should I say the equation of 0 times -1 plus 2 negative times -5 plus 1 times 4, or also we can say express this into 0 times -1 minus 2 times -5 and plus 1 times 4, and the resulting existing equation will become 0 plus 2 times 10, which is because -2 times -5 is equals to +10, and then add this to the +4. So we got 2 times 10 is equals 20 plus 4 is equals 24. So our determinant of the said matrix is equals to 24. So that would be our determinant for the matrix A, 3 by 3 or 3 by 3 matrix. So we have here the sign pattern for cofactors in case for you to have your basis on how to find or the way of finding why the cofactor becomes negative like that. So savage thinking. So we have here our illustration of finalizing our cofactors as based on its sign pattern. So we got here positive, negative, positive, and negative, positive, negative. That would be our second column, and then our third column will be positive, negative, positive, and that is our basis for 3x3 matrix. And for n by n matrix, which is the n is represented as our row, and then the next second n is our column. So that would be depends on the numbers of the dimensions of our matrix. So that's all, everyone. I hope you learned about this video tutorial. Thank you. God bless.